All right, folks. So I'm going to go through the MVP charts worksheet with you guys. And basically, I just want to remind you that the way this works is I'm going to talk about each question individually. And what I'd prefer that you do is try the problems yourself um, and then check here to see if your answer matches up with what I got. Okay, so rather than kind of now you can, just go through this with the entire video step by step if you want, but it's going to be probably a lot better if you choose not to do that. Still, at the end of the day, it's up to you. So let's give it a shot. All right, so question one, first thing to realize, we got to be able to understand the situation. So it says object A is moving and object B is not. When they hit each other, object A comes to a complete stop and object B starts moving. Okay, so what I'm going to do is I'm going to go ahead and draw that so that I know kind of what's happening. So I've got, all right, so I've got object A, it says, is going to come to a complete stop. So velocity now is 0 meters per second. It's at rest. And then object B is going to start moving. And we don't know what the velocity is, but we are going to try to figure it out. That's the question, by the way. The question is, what is object B's velocity after the collision? All right, so let's go ahead and fill in some information here. Let's start with the before picture. So we know that object A is 2 kilograms. I'm going to go ahead and write that there. We know it's traveling at a velocity of 4 meters per second. We know that object B is 8 kilograms and it's traveling at a velocity of 0 meters per second because it's not moving at the beginning. Okay, other information we have from the after picture is that in the after picture, object A is now moving at a velocity of 0 meters per second. We do not know what the velocity of that is, so I like to write a question mark just so we don't forget that's what we're trying to figure out. This is 2 kilograms and this is 8 kilograms for their masses. All right, so I'm going to go ahead now and look at what boxes are missing. So I am missing the momentum for both objects before the crash. I'm missing the momentum for both objects after the crash. And I'm missing the velocity of object B after the crash. So I'm going to try to use some patterns in order to fill things in. I want to remind you, I'm going to write this in red, that the patterns in this chart are that you can add the masses on both sides and they should be equal. That's the law of conservation of momentum that tells us that. You can add the momentums on both sides and they should be equal. We know that from the law of conservation of momentum. And you can multiply mass times velocity to equal momentum. All right, so we can use these patterns just like we would in like a Sudoku chart in order to solve for any of the blank spaces. So the first thing we can do is we're going to go 2 times 4 is going to give us a momentum of 8 kilogram meters per second. Over here, 8 times 0 is going to give us a momentum of 0 kilogram meters per second for object B. Over here, 2 times 0 is going to give us a momentum of 0 kilogram meters per second. Now, we can't go down the row on this one because we only know the mass, not the mass and the velocity, or we would need to know 2 things in order to use that equation. What we can do is go across. Because of the law of conservation of momentum, we know that the total momentum, which over here is 8 kilogram meters per second, is going to equal the total momentum over here. So this side also has to equal 8. Well, what do you add to 0 in order to get 8? Well, it's 8. Okay, so we know that this has to be 8 kilogram meters per second in order for those to equal each other and accomplish the law of conservation of momentum. We also therefore know that the velocity must be 1 meter per second, because 8 times 1 is 8. All right, once we've done that, we've filled out everything, and our answer is right here. I'm going to go ahead and highlight it. Object B is moving at a velocity of 1 meter per second. Why is it moving so much slower than object A was at the beginning? Well, it's moving so much slower because it is so much heavier. It's always a good idea to check your answers by thinking about why they make sense. All right, we're going to go ahead and move on now to question number 2. So if you followed me for question number 1, my advice is that you go back or just skip this video, stop this video for a second, try question number 2 for yourself, and you can always come back and check how you did a little bit later. Okay, so hopefully you tried doing number 2 by yourself before you're watching this portion of the video, but if not, and you can use that, hopefully as a way to check your answer, or maybe you've tried it and you've gotten stuck and you want to see what you might have needed to work on. Okay, so here's the deal. For question number 2, it says object A is moving and object B is not. When they hit each other, object A and object B stick together and move to the right. What is their velocity after the collision? Now, I'm going to use a trick in order to solve this problem that you might not have thought of, but that's okay. Fair game. All right, so the first thing to do is draw the after picture. So in the after picture, we have object A and object B stuck together, all right? And it says they are moving to the right? And it asks us, what is their velocity after the collision? Highlight that, that's what we're trying to find out. And I'm gonna put a big question mark down here because this is what we're trying to solve. All right, next thing, I'm gonna go ahead and plug in all of my given information. All right, so I know that each one has a mass of 5 kilograms. I know that object B is not moving, so it has a velocity of 0 meters per second. I know that object A is moving at 4 meters per second. I know all of this just from looking at the picture up here. All right, in the after picture, I don't know too much. What I do know is I know that object A and object B have masses of 5 kilograms each. I also know they're stuck together. And here's how I'm going to use that. And this is the trick I was talking about. In other examples, you've seen me draw a column for object A and a column for object B, just like I did right here, right? This is the object A column. This is the object B column. The reason I do that is because they're moving at different velocities, and so I need to treat them as separate objects. However, in this problem, they're stuck together, and so it's easier to think about them as one object because they need to be moving at the same velocity anyway. So instead of doing, 5 kilograms and 5 kilograms, I'm going to treat it as one object with a mass of 10 kilograms, okay? That's just a simple trick. I can only do that because they're stuck together, okay? So in every collision problem we do with an MVP chart, you have to think about, is it stuck together or not? And that will determine what you can and can't do. All right. Moving back over here, we're going to go ahead and start using the patterns on the chart in order to help us solve. One of the most important patterns on the chart is that the mass times the velocity is the momentum, and we're going to go ahead and fill out everything we can using that strategy. So 5 times 4 is going to be 20 kilogram meters per second. 5 times 0 is 0 kilogram meters per second. And then 10 times question mark, we don't know. We're just going to have to leave it for right now. The other patterns on the chart that are useful, and I'm going to draw these in red, are, remember, the law of conservation of mass, which says that we can add the things across the top row. The mass before and the mass after are going to be equal. There's also the law of conservation of momentum, which tells us that the momentum before and the momentum after are going to be equal. I want to remind you, there is no rule here, okay? There is no law of conservation of velocity, so you can't use the velocity row to help you. All right, so how do we use this? Well, we're going to look at the bottom row and see that this side has a total momentum of 20 kilogram meters per second. We know that that has to equal the momentum over here. And since there's only one object, because they're stuck together, I can go ahead and say that we know that this object has to have a momentum of 20 kilogram meters per second so that those two sides equal each other. The other thing, oops, that was a big erase. The other thing we know is that since 10 times the velocity equals 20, we can take a good solid guess that the velocity is 2 meters per second. Okay, 10 times 2 is 20. Once we've done that, we have solved the problem. Our answer is right here. The velocity is 2 meters per second. All right, if you've done that one with me, I want you to go ahead and try number 3. Don't just watch this video. You need to learn how to do it yourself. You can get stuck. You can try it. You can get stuck. You can come back to the video if you need to. But this is going to be faster and better if you're solving these by yourself. All right. Now, assuming that you've already done problems number 1 and problem 1 and 2 without assistance, we're going to go ahead and go to problem number 3. Hopefully you've tried problem number 3 by yourself, and either you finished it and you want to see how you did, or you're stuck and you want to get some help. So here we go. Problem number 3 says object A is moving and object B is not. When they hit each other, object A bounces back to the left at -5 meters per second. Remember, negative because it's moving left instead of right. And object B moves to the right at 10 meters per second. What is object B's mass? So that's what we're trying to find. All right, so let's draw our after picture. Object A is going to bounce back this way to the left and be moving at a velocity of -5 meters per second. Object B is going to be moving to the right at a velocity of 10 meters per second. All right? So if that's the case, what is the mass of object B? I'm just going to go ahead and plug in a question mark under object B on both sides because that's what we're going to be trying to solve for. Then I'm going to go in and plug in all of my given information. So I know that object A has a mass of 10 kilograms. I know that it has a velocity of 15 meters per second. I know that object B has a velocity of 0 meters per second at the beginning. At the end, I know that object A has a velocity of negative, the negative is very important, 5 meters per second because it's moving to the left. I know that object B has a velocity of 10 meters per second because it's moving to the right. I know that the mass of object A was 10 kilograms at the beginning, and so it's going to be 10 kilograms also at the end. All right. So what can I do now? I'm going to use the patterns in the chart to help me answer the rest of my questions. The first pattern that we usually think about is that mass times velocity is the momentum. That's the equation for momentum. So I'm going to go in and plug in as much as I can using that information. So 10 times 15 is going to give me a momentum of 150 kilogram meters per second. For object B, I'm going to skip this one for a second. Let's move on. We'll come back to object B. For object A here after the collision, we have a mass of 10 and a velocity of -5. Multiply those together and we'll get a momentum of -50 kilogram meters per second. I don't know if you saw that. I tried to dismiss my notification, which was on my iPad, on my laptop, using my finger. Everything about that was wrong. All right, so now I don't really know anything here or here. And there's a good chance that you're watching this video because you got to this point and you got stuck. Or you may have made the wrong choice after this. So the hard part to realize is this column. All right, you got to think like a mathematician here for a second. We don't know this number, but we can still solve for the momentum. And the moment I said that, you probably figured it out, because anything times 0 is 0. So we're going to go ahead and plug that in as 0 kilogram meters per second right there. Okay, the other patterns that we know, once again, are we have the law of conservation of momentum, which tells us the total mass before is going to equal the total mass after. Okay, it's not going to help us right now, but that is a law. The other law we have is the law of conservation of momentum, which tells us that the total momentum before a collision is equal to the total momentum after a collision. Now, there is no rule for the velocities. You may have tried using the velocities to solve this problem. You can't do that. All right. So how is this helpful? Well, if you look at the bottom row, you'll see that we have 3 things filled out and we have only 1 empty space. Anytime we have only 1 empty space, that is going to help us solve the problem. So on the left side, our total is 150. On the right side, we have -50 plus something. So the question is, what can we add to -50 to get positive 150? And the answer is we can add positive 200 and if we do that, we will get a balanced situation for our momentums. All right, once I know that that is 200, I now have some important information right here, because I know that the mass times 10 equals 200, and therefore the mass must be 20 kilograms. 20 times 10 is 200. If that's the mass over there, then it must be the mass over here too, because, you know, it's the same object. We're going to go ahead and highlight that answer because that's what we were trying to find out, was the mass of object B. The answer is 20 kilograms. All right, we have only one last question, but I want you to try to solve it first, okay? You got to have some academic honesty here, so give it your best shot. Try to solve question number 4. If you get stuck, you're welcome to come back to the video to get some help, to get unstuck, to check your answer, whatever you want to do, and we'll go from there. All right, so hopefully you tried question number 4. I know for a fact, I see you, student. I know that one of you is just watching this whole video and copying every single thing down. See how that works for you. That's your choice. But for most of you, I know that you tried the question because you're too bored listening to my voice to just sit here and watch the whole video and copy it down. So that's fine. Let's go ahead and try this one. We've got object A and object B are moving toward each other. When they hit, both objects come to a complete stop. What is the mass of object B? Alrighty then. So we're going to go ahead and draw the after picture here really quick. And what the after picture tells us is that these 2 objects, when they collide, are going to have a velocity of 0 meters per second, because it says they come to a complete stop. And we're going to go ahead and start filling in all of our given information now. So for the beginning of this, we have a mass for object A of 6 kilograms. We do not know the mass of object B. That's what we're trying to find out. Object A has a velocity of 2 meters per second. And object B has a velocity of -3 meters per second. That negative sign is very important. It tells us that object B is going to the left, whereas object A was moving to the right. All right, over here in the after picture, we still know that object A has a mass of 6 kilograms. And we don't know what object B's mass is. Now, some of you guys might have watched earlier in the video where I said that if two objects are moving together, you can just have one column over here and just write the mass of the one object. And we can absolutely do that here. However, it's just not that helpful because we don't know the mass of that object. So I am going to treat it still as two separate objects. I'm just going to remember that they have the same velocity, and that velocity is 0 meters per second for both of them. All right. Now that we have all of the given information written out, the next thing we have to do is think about the patterns. And if you watch this whole video, you're probably pretty tired of me saying what the patterns are. But too bad. So the patterns are that in the top, first of all, going down, we know that the mass times the velocity equals the momentum. So let's go ahead and use that as much as we can. All right, so we know that this 6 times 2 is going to be 12 kilogram meters per second over here. For object B, we cannot find its momentum by going down because we don't know the mass. For object A over here, we know that 6 times 0 is 0 kilogram meters per second. Now for this fun fact. This is always a tricky one. People get stuck here. They don't know what to do. But I want to point out to you that you can answer the momentum of this object. Even though you don't know the mass, anything times 0 is going to be 0. And so since this object is not moving, we know it has a momentum of 0 kilogram meters per second. Alrighty then. So we have most of this figured out, but we need to still think about the other patterns. So we know that mass times velocity is momentum, and we can use that going down the column. But what we don't know is how to solve going across. So we need to know the law of conservation of mass, which tells us that if you add up all the masses before the crash and after the crash, they should be the same. This also, by the way, is going to come back to you in chemistry next year when they talk about law of conservation of mass for chemical equations and things like that. Down at the bottom, we have the law of conservation of momentum, which tells us that the momentum before an event is equal to the momentum after an event. In the middle row, when we're talking about velocity, there is no law. So you cannot use the momentums going across to help you answer these questions. All right. Then what we can do is we see that we have 3 numbers in this row and only 1 thing missing, which means we can solve for that last thing. So since on the right-hand side, it's going to be 0, and on the left-hand side, we have positive 12, we know that it's going to be negative 12 kilogram meters per second right here. All right? At this point, you can do the rest. You can solve for that, and you can find what the phrase conservation of momentum means. I'm going to stop this video because my son just walked in. I need to give him a hug. I hope you're having a great day. See you later. What's up, bud?